So here at Synopsys, we've been working on CXL for quite some time, actually even before the release of the CXL specification. And we've introduced solutions for CXL 1.0, 1.1, 2.0, and now CXL 3. And of course, all of our solutions support the complete specifications, and they include a complete solution, meaning controller, PHY, verification IP, and even we can wrap around services to help produce a subsystem for you if you're interested in that. And before going too much further into the CXL itself, it's worth taking a look back at where this came from. This was really started as a spec to enable the growth and enhanced acceleration. So to make accelerators work more efficiently with CPUs, be able to share memory coherently. It introduced coherence and really low latency to a spec that's already very pervasive in the industry called PCI Express, I think you're all familiar with. And it's become really interesting to a lot of applications, ranging from AI machine learning to networking. Memory expansion has become really important with the ability to fan out memory and have multiple applications sharing memory. I'll talk a little bit more about that. And then general purpose acceleration applications as well. Now, to create our CXL controller IP at Synopsys, we started with a really solid foundation of our PCI Express 5.0 controller. That solution, together with the PHY, has been licensed hundreds of times. We have customers in production with it, so it's really solid. And that becomes part of the CXL solution. If you look at this diagram here on the CXL.io side, that effectively is the PCI Express 5.0 controller. And then over on the .cache mem side, there's new development that we did and integrated these together into a single package called our CXL 2.0 controller. Similarly, for CXL3, we have something that looks very much like this. A few changes. We're doing the CXL.io is now leveraging the PCI Express 6.0 controller from Synopsys. It uses the 6.0 PHY down at the bottom and still has the .cache mem. But now we've also got something introduced that we call multi-stream, which allows us to parallelize some of these interfaces to get higher throughput for some of these really wide connections. And of course, we're supporting all three of these protocols. When you mix and match the I/O, the .cache, and the .mem, you can get three device types called type 1, which is essentially using the CXL.cache to allow the device to cache host memory. Type 2 devices, which are doing the same as type 1, plus allowing the host to access and map device memory into its memory space. And then type 3 devices, which are essentially memory expanders that are only leveraging the CXL.mem together with the CXL.io. So at Synopsys, our IP supports all three of those, and it's up to the customer how they want to configure that. One of the cool things that has come about from CXL is this idea of not just of memory expansion, but actually memory pooling, which was introduced with CXL 2.0. So if you look at this diagram, it's showing multiple hosts connected to a CXL2 switch, and below them a series of devices are connected. And within those, I've got color-coded memory kind of showing different memory regions that are allocated to different hosts. So even though the devices have this memory local attached to those devices, you can see how the different hosts can all make use of using that different memory across those different devices. We call this memory pooling because it's as if all of the devices in the system pool their memory, and then the host can choose which memory they want to use out of that pool. And this requires, to really get the best benefit in multiple logic devices, this is something we support within our CXL controller IP. And of course, we support this. And interestingly, if you look at this in particular, you need a CXL2 switch to implement this. And for that, you need CXL switch port IP, which we also provide from Synopsys. So one of the things we're finding at Synopsys with a lot of our customers today is that they're also interested in security. And by that, I mean the IDE specification, both for CXL and for PCI Express. Started at PCI Express, now CXL has an IDE ECN to the specification as well. And so what we've done at Synopsys is introduced a complete CXL IDE solution. We rolled that out for 2.0 and have lots of customers integrating that today. And we have a CXL IDE module that connects directly together with our CXL2 controller. And for CXL3, we're developing the same thing and are introducing that to our initial customers as well. With our CXL controllers, we actually provide some verification IP for our customers so they can verify the controller configurations they create and the connection between their CXL controller and their PCI Express Gen 5 or Gen 6 PHYs. And in this VIP, there's a lot of capability. And as we move to 3.0, CXL 3.0, we're able to verify protocol features, a PCI Express mode versus CXL mode, the various flip modes from 68 byte to 256 byte, the VLSM and power management capabilities, viral, the backend validation, Snoops, all kinds of things within the CXL specification can be verified using the Synopsys verification IP. So all this bundled together becomes what I've been referring to as our complete CXL solution. And again, that's the PHY, if you look at the top of this diagram, the controller, if you look at the top of this diagram, the PHY that it talks to the outside world. And then in this diagram, I'm also showing the IP subsystems, which is an optional service we can provide at Synopsys to build something like complex CXL multiple controllers that are connected together with clocking and reset logic and even hardened PHYs, things like that. And then we have the CXL verification IP. And then we actually already have hardware prototyping kits too, to enable your own hardware prototyping. So the final thing I wanted to just touch on too is how we're working with the ecosystem. And so this is really important. For new specs like CXL, it becomes really critical to be able to do interoperability, to do compliance, and all those things very early so that our early adopter customers can create their silicon with very low risk. So one of the things we're doing is going to the compliance workshops. Of course, they're just in their very beginning stages for CXL. We had a first pre-FYI testing that just took place, and there's going to be follow-on ones, will be FYI, and then eventually real compliance testing. So at that, we were able to connect our host, the CXL host, with other CXL devices, as well as our CXL devices to other CXL hosts. And so part of this, we did interoperability with the Intel Sapphire Rapids platform that is already public information, and we interoperated with a couple other host providers as well. So lots of that stuff going on. But then another thing that we're doing is we're enhancing our CXL controller offerings with some advanced features intended to make really high performance ARM-based server SoCs. And if you look at this diagram, this is showing one of the collaborations that we've done with ARM, where they're taking Synopsys IP, they're taking their CXL dual mode controller. Dual mode means it can be configured as endpoint or root complex, and Synopsys DDR memory controller, and connecting it into their coherent mesh network and their SMMU, connecting to an ARM CPU, so that the whole thing can make a complete SoC. And they can do this and then teach their customers, our mutual customers, how to do this more easily and include some performance information. So we're going to be doing more and more of this kind of collaboration, and are very excited about this as CXL2 spec and CXL3 comes out. And speaking of CXL3, I think you've probably heard by now that the 3.0 spec was just announced. And this is introducing a whole bunch of additional capabilities. It's really moving us towards fabrics and complete disaggregation of our systems that so many people have been working toward. Includes more efficient peer-to-peer communications, more fine-grained resource sharing, which moves beyond pooling to something that can be called memory sharing. So you'll see a lot more about that at the Flash Memory Summit. And we're just very excited to be part of the CXL consortium and to be able to offer this proven IP for you and your designs. So that's all I had to cover, and I want to thank you for watching.